Friday, October 21st, 1948, in a cramped, smoke-filled hotel room in Dayton, Ohio. Three hardcore Boeing aeronautical engineers, Ed Wells, George Scherer, and Von Blumenthal, swept outdated propeller blueprints off the floor. In exactly one insane weekend, they sketched a colossal, roaring jet monster that would permanently alter human warfare. That was not merely an airplane. It is a 220-ton flying power plant, forged with one ruthless, singular purpose: dropping 31.5 tons of high explosives directly onto the enemy's head from the silent stratosphere. Let us violently strip away every single layer of the B-52 Stratofortress's aluminum skin to witness exactly what primitive, brutal, yet chillingly precise mechanical systems American engineers crammed inside this 70-year-old flying guillotine. Peeling back the exterior Duralumin 2024 alloy skin, we face a gigantic structural framework stretching 48.5 meters long. Its wingspan spans 56.4 meters, equivalent to ripping a 15-story building from its foundation, laying it sideways, and forcing it to tear through the sky. The maximum takeoff weight of 220,000 kilograms generates a monstrous shear stress that constantly attempts to rip the physical structure apart. To counteract this tearing force, the primary load-bearing longerons are forged from solid, high-strength steel, carrying the entire weight of the cockpit and the massive central bomb bay. Every single titanium rivet is driven by high-pressure hydraulic presses to lock the fuselage panels, preventing atmospheric pressure from shredding the machine at an altitude of 15 kilometers. But the most terrifying mechanical secret, a marvel of materials science, lies within those fuel-stuffed wings. You are looking at two gigantic internal cavities firmly holding 179,000 liters of highly flammable JP-8 aviation fuel. This volume is enough to fill thousands of civilian cars, now crammed into a metal structure suspended tens of thousands of meters above the Earth. When flying through severe atmospheric turbulence, extreme wind pressure and temperature differentials of -50 degrees Celsius continuously bend the entire metal wing frame. The B-52's wings are not rigid. They are engineered with an insane mechanical elasticity, capable of flexing up and down with an arc of up to 9.7 meters. Imagine the elastic deflection of the massive steel suspension cables on the Golden Gate Bridge straining against a super typhoon. These wings endure a similar tensile force without shattering. Engineers calculated the perfect yield point for the aluminum alloy, turning the wings into two colossal shock-absorbing springs slapping the air. If the airframe is the skeleton, the heart-pumping blood into this beast is a brutal cluster of 8 jet engines, driving deep into the Pratt Whitney TF33 turbofan engine clusters mounted on 4 solid alloy pylons beneath the wings. We are dissecting a blazing furnace. The front titanium compressor blades spin at tens of thousands of revolutions per minute, acting like a gargantuan industrial vacuum cleaner devouring tons of freezing air. The high-pressure compressor system squeezes this airflow, ramming it straight into a combustion chamber roaring at over 1,000 degrees Celsius, hotter than the melting point of pure aluminum. The violent thermal expansion forces the glowing exhaust gas out the rear, generating a maximum combined thrust of 136,000 pounds. The screaming sound from these 8 metal blocks tearing the air hits a deafening frequency, a sonic wave carrying enough physical energy to rupture the eardrums and crush the chest of any ground technician standing 50 meters away without protective gear. This demonic thrust lifts the 220-ton mass, propelling it at a cruising speed of 900 kilometers per hour. However, Forcing such a bulky, colossal steel mass to take off and land requires a ground-gripping mechanism that defies standard physical laws. Focus directly on the exceptionally rare crosswind landing gear system of the B-52. It does not land perfectly straight and perpendicular like civilian commercial aircraft. A massive hydraulic pivot is installed, allowing the entire 8-wheel load-bearing assembly to rotate laterally up to a maximum angle of 20 degrees. This off-axis mechanical structure allows the fuselage to slide sideways against vicious crosswinds, while the wheels roll perfectly straight and parallel to the runway centerline. Visualize the immense friction generated when 220 tons of metal slam directly onto the concrete runway at a velocity of 250 kilometers per hour. The reinforced rubber tire surface is instantly crushed, smoking heavily as the temperature at the contact point spikes to hundreds of degrees Celsius in milliseconds. Simultaneously, the multi-disc carbon ceramic brake system clamps down, glowing red-hot like coal in an industrial forge to suppress the monster's destructive inertia. But forcing 220 tons of metal to take off and plow through the sky is just a basic aerodynamic equation. The true nightmare, the most horrific life-reaping mechanism, lies dormant in the colossal mechanical tumor hidden deep inside its belly, where the life or death of tens of thousands of people below is decided. Stripping open the colossal bomb bay doors reveals the common strategic rotary launcher, a terrifying mechanical matrix of high-carbon steel gears, thick hydraulic hoses, and heavy-duty locking clamps. A massive, high-torque electric motor physically rotates the central titanium cylinder, groaning under the sheer weight as it precisely aligns each thermonuclear or conventional warhead into the exact drop position. This is not a seamless digital game. It is brutal. Heavy machinery manipulating 31.5 tons of pure explosive power. The instant 108 Mark 82 bombs forcefully disconnect from the underwing external pylons and the internal rotary racks. The entire aircraft experiences a violent, heart-stopping aerodynamic shift. Losing 31,500 kilograms of dead weight in a matter of a few terrifying seconds forces the massive aluminum fuselage to jerk violently upward, fighting gravity. The pilots must physically wrestle the heavy control column, muscles straining, to prevent an immediate aerodynamic stall and keep the nose leveled against the sudden upward surge. Trace the terrifying trajectory of those falling steel cylinders plummeting toward the Earth. Gravity aggressively accelerates them to their terminal velocity, slicing through the freezing air and turning them into kinetic meteorites long before their internal fuses even trigger detonation. Upon impact, the supersonic shockwave instantly compresses the surrounding air into a solid wall of pressure, ripping apart 2.5 square kilometers of the Earth's surface in a fraction of a second, completely transforming the terrain into a sterile, cratered lunar landscape. The extreme atmospheric overpressure radiating outward from the blast epicenter is a lethal, invisible wall of force, fully capable of collapsing lungs and shattering the rib cages of anyone standing hundreds of meters away. This is the brutal, unforgiving physics of strategic carpet bombing, mathematically calculated by engineers to erase entire coordinate grids from the map. Yet, the most shocking and archaic reality lies heavily behind the armored cockpit door. There is absolutely no modern, computerized, fly-by-wire electronic flight control system guiding this apocalyptic, world-ending bomber. The human pilots must manually maneuver this 220-ton flying behemoth by physically pulling hundreds of meters of tightly braided steel cables routed through a complex maze of primitive pulley wheels, stretching all the way to the massive tail rudder and wing flaps. It is a terrifying, exhausting test of pure human muscle and mechanical leverage constantly straining against the immense, tearing friction of the atmosphere, forcing men to physically wrestle with a machine built in an era long before microchips existed. The B-52 Stratofortress is not a sleek, futuristic sci-fi marvel of clean lines and quiet engines. It is the absolute pinnacle of 1950s mechanical violence. A ruthless, heavy patchwork of riveted aluminum alloy, thick steel cables, and 8 screaming jet turbines devouring the thin sky. A machine casually sketched on a hotel napkin in 1948 will stubbornly continue to drop heavy payloads until the year 2050, serving an unprecedented, bloody full century of relentless warfare. So how exactly does this incredibly slow, massive analog dinosaur avoid being instantly shredded into burning scrap metal by hundreds of supersonic, radar-guided SAM-2 missiles launched from the ground? Do not forget to subscribe to the channel and leave a comment below. Next week, we will aggressively dissect the B-52's highly classified electronic warfare armor, peeling back the invisible electromagnetic shield that effectively blinded the world's most advanced air defense systems.